Hey, this is Brock Lemires, and in this video I'm going to continue talking about AC signals and specifically the cost of electricity. Okay, so we've been talking about the electrical power grid, and we know that it's it's AC signal based for the most part. And so the question was like, how do you tell how much you have to pay for electricity? So I just pulled a rate sheet at a glance from Northwestern Energy, which is a utility company in Montana, and this is for September 1st, 2020. And you'll notice that they list out all the charges that they have for electricity. But the first thing that you notice right away is that they give the cost in what's called kilowatt hours. Okay, so it's kind of a new unit for it. So it's like, what is this thing? But we'll go through what that is. So if you look at all the costs that go into everything, the total cost is $0.117 per kilowatt hour. Okay, so that's how much it costs. What goes into that is kind of interesting because you can see you have like supply, right? And then you have like deferred cost, but the supply is like the generation. Then you have taxes, quite a bit. Then you have transmission, which is the long haul lines. Then you have distribution, which is the distribution throughout the city. And then of course taxes. And then you got some other stuff in here that nobody knows. But so basically you can kind of think of it as breaking it down into four main categories. You have generation cost, transmission cost, distribution cost, and taxes. Okay, so this changes from month to month, but in general, let's just use the value 11.7 cents per kilowatt hour. So then the question becomes, what is a kilowatt hour? And one of the ways to introduce this is to think about the notion of how you pay for something that comes into your house as a rate. Okay, so let's just do an analogy of water. Okay, so you have water, and this is going to be a faucet, let's say. There's a water drop. And when you have water that comes into your house, what happens is that they have meters on it. Okay, so you're gonna have a meter, but meters really measure the rate of things. They don't measure the absolute volume that has gone by. What they do is they measure a rate. So you would get something out of your meter that is like gallons per, hour or something like that. And depending, if you increase more, you draw more water, your gallons per hour would go up. If you have less, you have lower gallons per hour, but it's a rate, right? And then the meter also measures time. Okay, and so, but what do you pay for? Well, ultimately, if somebody's selling you water, you're going to pay for gallons of water, so the amount of water that you use. But just due to the way that the meters work, they give you gallons per time, and then you have to multiply it by the time that you pulled water at that rate. Okay, so for example, if I had, let's do an example of water where I'm gonna pay something like $1 per gallon, which is quite a bit of money for for water. But if you had something like, I pulled 5 gallons over 5 gallons per hour, that's my rate coming out of my meter, but I pulled that for a half an hour. Okay, then what would happen is you could say, well, you consume 2.5 gallons of water, and that's what you're charged for. Okay, so then I'd pay $2.5. Okay, so anyway, the reason I do that analogy is because that's how power works too. So if you remember, power is a rate. Okay, so watt is actually joules per second. Okay, and so when the analogy of like gallons with water, we're actually trying to figure out like how many joules did we actually use. Okay, what is the quantity of joules, and that's what we ultimately pay for. And if you think about power, it's like, just to review, it's power is equal to IV. Current is, the definition of that is coulombs per second, right? So that's the number of number of coulombs that pass by a point per second. And then voltage is energy, which is joules per coulomb. So how much energy does it take to move those coulombs? And you ended up with joules per second. But remember, power is like a rate. So when I say that my house is consuming 10 watts, that's like a continuous flow of joules into my house. Now the human brain doesn't really think too much in terms of joules, but you can think of it about as like it's just like it's flowing electrons into your house, and so there's cost associated with that. Okay. So what happens is that things are rated in terms of some load, right? So you have some load, and it is going to consume some power. So let's say it was 10 watts. So what you have to do is you have to say, okay, it was 10 watts, but for how long did you pull at 10 watts? And so then you multiply that by time, and that's how you ultimately get to an answer that is then used with this cost per kilowatt hour, okay? So that's kind of the general overview of it. So let's do an example. That's really the best way to figure it out. Okay, so here we go. We have a light bulb, okay? So I'm gonna calculate a light bulb. All right, so you got a 60 watt light bulb, okay? Now it's called a 60 watt light bulb because it consumes 60 watts. And so we want to figure out, number one, how much money does it cost to run that light bulb? But you have this aspect of time in there. And so really what you want to know is how much per month is it, okay? Because you pay your utility bills per month. So it isn't really interesting to say, how much did it cost to run my light bulb for an hour? And it's like, well, you don't pay by the hour, you pay by the month. So we kind of figured it out. So we'll do an estimate of a month is 30 days, and there's 24 hours per day. And so in a given month, you have 24 hours times 30 days. So there are 720 hours per month. So that's going to be a unit that we care about at some point. Okay, and so then the next thing that we have is you were going to have 60 watts, okay? And immediately you know that the cost of electricity is given as 11.7 cents per kilowatt hour, okay? So you have to convert everything to kilowatts immediately. So you immediately have to take this and convert it to kilowatts. So what I'm gonna do is I'm gonna say that I want the watts on bottom and kilowatts on top. So I'm gonna say 1 kilowatts is equal to 1,000 watts. And so this right now gives me my power in kilowatts. That's good. And now you have to multiply that by your time. And now here's where it is interesting, because you have to take an estimate of how many hours in the month did you actually have the lights on. And so now this is where everybody is a little bit different. So you might say, well, I had one bulb on for 8 hours a day. And it's like, well, how many bulbs do you have in your house, right? And so let's just do a simple one where you said, I have 8 hours a day multiplied by 30 days. Okay, so I'm gonna run this bulb 240 hours per month. Okay, so that's per month. And now I have something that would result in a unit of cancel. I would have kilowatt hours. Okay, so now if I wanted, so this right here would give me kilowatt hours, and so let me do that. So it's like this gives me kilowatt hour, but now ultimately what I can do is, instead of doing the equal, let's just multiply it by the actual rate, and that's going to be finally dollars, and that's going to be 0.117, okay, dollars per kilowatt hour. Okay, so then that gives me the amount. Now, why did I put 720 hours per month? It's to kind of remind you, it's like you're not going to have like 1,000 hours in a month. Okay, based on how much you use, okay? Okay, so let's do this. So I'm going to go 60, and then I'll do times 240 times 0.117 equals, and then I'm going to divide that whole thing by 1,000, and it turns out that it cost $1.68 in order to run a 60 watt light bulb 8 hours a day for 1 month. Okay, not terrible. Okay, not terrible at all. All right, life is good. Let's look at some of the other things in your house that you might use electricity on. 65-inch TV. It's twice as much as running a light bulb. That, my friends, is unbelievable. So this amazing TV is only twice as much power as a light bulb. That's pretty amazing. How about an air conditioner? Okay, that's a big dog, 2,600 watts. PlayStation 4, again, not very much, right? It's like 85 watts. That's less than a TV, but it's just a little bit more than a light bulb. Router, 4 watts. That's almost getting down to hardly anything. And then this is a fascinating one. This is like a huge amount of power. Hair dryers. Hair dryers take a lot of power for some reason. Well, it's not for some reason. They use electricity and they heat up wires and then they blow a fan out and give you hot air. So if you look at your top consumers, just roughly, your air conditioning is a huge one, right? So it's 2,600 watts when it's on. So it usually comes on, like 4 or 5 times an hour. So it's not on all the time, but it is when it comes on, it's huge. Electric water heaters. These things are massive amounts of power. Okay, that is this electric water heater, 4,500 watts. That's the reason that most water heaters are natural gas, because it's so expensive to heat it with electricity. Now the downside of it is that natural gas is a fossil fuel, so it's not the greatest thing in the world. Refrigerator, 225 watts. Not a ton, but it's on more than other things, right? If you open your freezer, it's almost always running, and so the refrigerator is on a higher percentage of the time. Electric water heater is not on all the time, right? You heat up the water and then you shut it off and then you wait till you use it and then you heat it up again. Washer and dryer, 3,000, huge amount. But again, you only use it how much? A couple hours a week, maybe? A couple, maybe? And then you got your oven, 2,500. Now, what do you notice here? The huge power draws in a house are from your appliances, but electronics are like nothing. So 65-inch TV is 120 watts. Okay, that's nothing. Your router is nothing. Electronics just don't take that much power. But let's do one more calculation. Okay, let's do the router. Okay, so let's do the Wi-Fi router just to show kind of what that is. Now, here's the Wi-Fi router. Now, here's what I contend to you. Okay. I think the router's on 720 hours a month. And I say that because the router's always going. It's always plugged in. It's always looking for stuff. It's always, even if you're not transmitting information, it's always looking for you. And then it's always doing updates and everything. So I will contend that your router's running 720 hours a month. So let's figure out how much that costs. Let's do another example. Okay, so the router is going to be 4 watts. Okay, but I need to convert that into kilowatts. So I'm going to go 1 kilowatts is the same as 1,000 watts. So now that has given me my power usage in kilowatts. And then I'm going to multiply that by hours. Turn blue here. So I'm going to multiply that by hours. And I'm going a full 720 hours. And where did I get that? That's from 8 hours, 24 hours a day, 30 days in a month. So 720 hours means this thing's running 24 hours a day every single day in the month. Okay. And then let's take that. So now this has given me kilowatt hour. And now what I'm going to do is I'm going to multiply that by price per kilowatt hour. And then you don't put the hour there. And then what happens is that the kilowatt hours will cancel and I'll be left with only this. So now let's come in with the cost. I'm going to switch back to red. And I'm going to have 11.7 cents or $0.117 per kilowatt hour. Okay, so now let's see what the old Wi-Fi takes to run. Okay, so I'm going to come in here and I'm going to say, okay, 4 watts times 720 times 0.117 equals, so that's my numerator. I'm going to divide that by 1,000. And the answer, oh boy, 33 cents. That is so low, I'm going to check it one more time. So it's going to be 4 watts times 720 times 0.117 equals, divided by 1,000. That is not a lot of money. So 4 times 720 times 0.117 equals, divided by 1,000. Holy moly, that is absolutely nothing. So for a little over a quarter, okay, you can run your Wi-Fi router for an entire month. Isn't that awesome? Okay, so that is it. That's how you actually calculate the power of things in your home. Okay, it's pretty simple, but it's also something that not a lot of people think about. They just get their utility bill and go, oh, that's cool. But anyway, that's how you do it. All right, so that is it, and see ya.